Oh, exponents. Okay.
So exponent is something we see, like say 2 to the third and 4 to the fifth. And
Mhm.
it's really,
Yeah.
it's nothing, it's basically still the multiplication. And it just, this is something, it's called shorthand. And you guys use shorthands, right?
Yes.
Okay, like LOL, that's shorthand.
Mhm.
And IDK, that's a shorthand. It's not something you can do that pretty fast. And so when we look at 4 to the fifth, what that means is 4 times 4 times 4 times 4 times 4. Then you pretty much get tired of it. So instead of doing that, you say, okay, we got 4 multiply. So sorry, 5, 4 multiply. We just write at 4 to the fifth. And this means that we got 3, 2 multiply. And those are not that if we just only up to fifth and third, then it's it's okay. It doesn't save that much time. But what happens if you're dealing with, say, um, 3 times 3 times 3 times 3, and all we do got like 100 of those? Well, that 3 to the hundredth power would be a lot easier to write and saves a lot of time. Good? Yeah. So it's nothing special. It's just a shorthand. But because of that, then we have the operations of exponent. For example, uh, 2 to the second times 2 to the third. Well, what's that? Well, we can see that 2 to the second is just 2 times 2, and 2 to the third just 3 2 times. So therefore, we got 5 to multiply, so 2 to the fifth. And so it's pretty simple, right? We got 2 twos, we got 3 twos. All together, just 2 plus 3 equals 5. And if we got, say, 3 to the fifth times 3 to the ninth, then I just 3 to the 14th. Pretty straightforward, right?
Mhm.
Yeah. So this actually, when we write it, we write like this. The formula is x to the nth power and x to the mth power. We write as x n plus m, because we do have nx, we have mx. So of course, together we got n2 plus m. Yep. We good on this one? Now the key here is the base has to be the same. Otherwise, like x to the nth times y to the m's, that's not equal to x n plus m, not equal to y n plus m, and definitely not equals to x times y n plus m, because those we have different base. And so this only works when we have same base. It's basically important. Now, we call this number as our base, and on the top here, we call that exponent. So just a kind of a term for that. Okay, we good on this one? So that's our first formula. Then we're looking at what do we mean by, say, 4/5 divided by 4/3. Well, we know this, we got 5/4. Then we got 3/4 on the bottom. We can see that this got canceled, this got canceled, this got canceled. We got 4 to the second. So therefore, if we want to do 4 to the fifth divided by 4 to the third, we just simply do a subtraction. You can see that this got canceled, this got canceled, this got canceled. So 3, so uh 4/5 divided by 4/3 is just 4/5 minus 3 as 4 to the second. Good.
Mhm.
Hello, Jed. How are you doing? And
Doing great. How about you?
doing good. So we are doing a review on exponent, and
Okay.
we're going to talk about exponential functions. Okay.
Okay.
Now, so we got this formula, which is x n minus n. Good,
All right.
right? just look at here. When we did that, we basically just, when we canceling, just like we take a subtraction. We just get rid of those, the common, on the top and bottom. Yep. Are we good here?
Yes. Oh, wait, hold on, let me copy this down.
Okay. And so now, so far we got 2. We say xn times x to the nth power, which is just xn plus m. And when we got xn divided by xm, it's just xn minus m. Then we're going to looking at what we mean by, if we do like 2 to the third and parenthesis to the second, well, what's that? This, remember, this is the base to this exponent. That means we got 2 to the third multiply. And actually that gave us 2 to the 6. And you can see that 2 times 3 is 6, because we do have 2 of those together. If we got 5 third and to the 4th, what we have? This is our base to this exponent. So that's 4 of those. Now, then we're going to add all 3 together. We got 4 3s. So it's 5, 3 times 4 is 5 to the 12th.
To the 12th. Oh,
Good?
okay.
So that's why when you have parentheses and that become multiplication. So we got x n parenthesis m equal to x n times m. Yep. We good? Okay. So now we have some special case. One is what happens if the zeroth power? Well, see, what do we mean by zeroth power? Well, x zeroth power will be same as x2 minus 2, right? Well, it could be x3 minus 3, doesn't matter because we got 0. Well, what is x to 2 minus 2? According to this formula, see we got there, it's just x to the second power over x second power. Well, that's the same quantity, so just 1. So that's why anything to the 0th power is always 1. Good?
Aye.
Yeah, so it's nothing magical about it. It's or nothing mystic. Just what it means. When we write x to the 0th power. Now, what is weird is this. 0 to the 0th power actually is 1. Okay. Now this is weird. But this is something we need for the math to work out. And we'll see that. Well, hopefully we'll see that someday. But at least once you get into calculus, you will see this. So this one is super weird. Yeah, because 0 to any power, 0 to the 1th power is 0, 0 to the nth power is 0, except this. That's a special case. Okay, just keep that in mind. Someday you're running into that. Okay, now we have that. Then what is means by negative power? So -5. Well, we can write this as x 0 minus 5, right? That's -5 is 0 minus 5. Then according to this formula, we got x to the 0th power and x to the 5th. So, but x to the 0th power is 1, and then we got x 5th. So now I can see that we can change the negative power to positive, but it's a reciprocal of that. We got this. So we have this formula, minus n equal to 1 over xn. Yeah, good. So once you understand those 3, then you'll be able to understand that, because just based on what we know here, we can just deriving. So those are the kind of formulas you run into when you do exponent. So, and that's the foundation for us to do exponential function. So now here is actually a question not many people will get right is, for example, now if say if you have do some work for 100 days, sorry, 10 days, you did something maybe for your parents or for your friends or your grandparents, and you get two proposals how to pay you. One is number one, okay, or A is you got $100 per day for 10 days. B, you got $1 for the first day, 2 for second, 4 for third, 8 for fourth. So each time multiply 2 and for 10 days. Which one would you choose?
So the $100 would be all 10 days.
Yep, every day you get $100.
So if I worked 10 days, I get $1,000.
Right.
But the other one it doubles. So
Yep.
Let's see here. I don't know.
Well,
I mean, depending on how long I work.
well, 10 days.
Let's see here. I'd probably go with probably A.
I'd go with B.
Okay. And 10V? What's your choice?
I would go with B.
Okay. Elsa?
Just a second. Sorry. I think I'm gonna go with A.
Okay. All right. Now A is straightforward. We got $1,000, right? Now for B, well, first day is 1, second day is 2, third day is 4, and fourth day is 8. And all together on the, so this is a 2 to the 1's power, 2 to the second, 2 to the third. So there are 10 days, 2 to the 9th, right?
Yeah.
Good? Yeah, are we good here?
All right.
Okay, so now how do we add them together? And if we do, now if we do a rounding average, rounding count, so after the first day you got $100 A, but you only got 1. On the second day you got 100, but accumulate is 200 after 2 days. And after 2 days you got 3, and then 300 you got what? You got 7, right? And 400 you got, then add 8, 15, and 500 is so that will be 2 to the 8th, then 2 to the 4th, 16, 16 add 15, 31. Now, okay, you want to change your mind so far? 600, we're going to add 2 to the 5th, 2 to the 5th is 32, 32 add 31 is 63. On the 7th day, we got 700 now, and 2 to the 6 is 64. So 63 plus 64, we got 127. And 800 We got 2 to the 7 now. 2 to the 7. 2 to the 7 is 128. 128 plus 127. We got 5 here. 5, 255. And on the ninth stage, 900. But then we got 2 to the 8, which is 128 times 2. That's 256. So 255, 256. We got 1 and 1 and 511. And what happened on the last day? You got 1,000.
Ooh, yeah, now I see.
Last day is 2 to the 9. 2 to the 9 is 256 times 2, 12. And 2 times 5 is 10. 2 times 2, 500, 512. So 512 plus 511, 3, 2, 10, 1,023. So he had $23 more than top one.
Yeah.
Good.
Yeah, I see what you mean. Yeah, it's an exponential. Wait, what sort of rate is that? Is that compounding rate?
Well, this, in banking, it's called compound interest. So the interest on interest. And
So this
that's
is
a typical exponential function. But here, this is more, this kind of increase, exponential each time double, this is more close to virus infection. Say one person infect 2 persons. And so you infect this person and this person, and this person got 2, 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 and this person got 2. Now, at the very beginning, it doesn't seem that much, but before you know it, it just shoot up. So we got something like this. This is called exponential function. It shoot up pretty quickly. Good. Yeah, that's why we always caught us in surprise when those virus infection comes, because it starts same small, but before you actually get uh, before you know it, it just explodes. Hello, Morgan. Yeah. Okay. So we're working on exponential functions. So this is example of that. Oh, sure.
Yeah, what's up?
What's that for? B equals
Uh,
$100 pound for Chick-fil-A
so
spicy chicken sandwich.
B also equals 201 spicy chicken sandwiches from Chick-fil-A. I calculated the price. I'm sorry.
wow.
Mm.
What
Okay.
does A equal?
All right.
A equals slightly less because you can get an additional, I believe, 3 spicy chicken sandwiches with that extra $24.
That's nice.
All right. Okay. So that's your favorite restaurant, Chick-fil-A?
No, I just go there the most.
Okay.
Wonder how many double quarter pounders you get with that.
Okay. Now, this actually is a famous story. Most likely it's not true, but it's a good story to have. Is talking about someone introduced to a king, the game of chess. Now, you guys know about chess, right?
Love playing it.
Okay, so we got what? 8 by 8, right? Let's see. Cut that to half, cut it to half. Now we got 8 by 8 squares. So someone actually introduced this game to a king, and the king was very pleased with it. And so he, of course, for king, he wants to give a reward. And so the person just said, and uh, my reward is that for the first square, put just one grain of rice. Second square, put 2 grain of rice. Third is put the 4, and fourth is 8. Okay, and I mean just every time just double by 2. So well, to the king, that's not much, uh, really not much a problem, right? Doesn't look like that much rice. What do you think if someone asking for this, if you are the king, would you take it?
I don't know.
Yes or no?
We could get out of hand pretty quickly.
Yeah. Well, so let's see. First time is 1, second time is 2, third time is 4, 2 to the second, then 2 to the 2 to the third, then 2 to the fourth, and 2 to the fifth, and all the way down to 2 to the 63, because that for that. But how
Wait,
big is that? Well,
wouldn't
let's
it be
find.
64th?
No, because first time is 2 to the 0.
Oh, yes, of
Okay,
course.
this is the first one, the second one, the third one, the 64. Good.
All right.
All right. So how do we calculate? Actually, there's a nice way to do the calculation. I mean, it looks like it take a long time, but with the help algebra, we can make things a lot easier. So this will be, of course, 1 plus 2 plus 2 to the second, all the way down to 2 to the 63. So now we are going to multiply on both sides by 2, so 2s. And of course, it's 2 plus 2 to the second plus 2 to the third, and all the way down to 2 to the 64, right? Are we good?
Yeah. All right.
Everybody is good?
Mhm.
Okay. So now the trick is if I use the bottom minus the top, 2s minus s is s, that's our sum. Well, what do you mean? How do we go from the bottom minus the top? Well, we can see those get canceled. And all we get canceled, except we got 2 to the 64 minus 1. And that is a lot easier to calculate. But what is 2 to the 64? Well, let's use that 2 to the 64. All right. I don't know if you're doing any calculation. I'll write it out for you. And this is something you probably wouldn't expect. So, by the way, just give a guess. How big is this number? Million, billion, trillion?
Infinity.
Um,
No, it's not infinity, but how big is that number?
Oh, I thought you were talking about like just numbers in general.
Give a
Um,
guess without using calculator. Give a guess.
couple billion.
I'm gonna guess
Some said billion.
uh sextillion,
What's that?
right? Uh,
Oh shoot.
Okay. And I count the amount of digits.
How many zeros? Okay. Someone guess the billions, some guess some trillions, some get maybe
Uh,
a
isn't
trillion,
that like 23 zeros?
23 zeros.
I
Okay.
think that's 23 zeros.
All right. Well, let's see.
3. Ah!
Let's see how big, yeah, without, okay. I mean, using calculator, you'll figure it out. I'm write down and see what's your
This
expectation.
is gonna take a while.
18, 400, 446, 744,
536 times
0,
2. Oh
73,
my gosh.
set, 09, 551, 616. That's how big it is. And,
Grains of rice?
yeah, this many grain of rice. I mean, we just don't have that. I mean, not for the whole world. Okay.
Goodness.
Yeah. Okay.
I'm doubling it currently, and I'm at 524,288 grains of rice.
Well, how many is that?
How
Thousand,
many?
billion, trillion?
I'm
What's
currently in the
under the
hundreds of thousands.
trillion?
Nah, I just
What's
breached a
before
million.
the trillion? How many? You can see 3,
100,
3, 3, 3, 3, 3. How many? What digit?
100,000,
1, 2,
million,
3,
billion,
4,
trillion,
5,
quintillion,
6.
sextillion.
About 20 digit. Well, you can also write in uh, scientific notation. Yeah, of course, the king had definitely won't be able to support that. Sextillion. Okay. Sextillion. All right. That means how many digit? Sextillion. 10 to the
60?
what? 10 to the what?
20th, maybe?
Okay. Well, anyway, so that just showed the power of exponential growth. Before you know it, it just explode on you. Okay. It's huge. Of course, the king really just can't pay it. But as a king, that there is always a solution. And do you know what's that solution?
Just, I don't know.
Well, off,
Give the value of the rice in gold.
no, off with his head.
Yeah.
Effective.
The king and queen always have a simple solution for all problems. Do you remember Alice in Wonderland, the queen? Yeah,
Yes.
would you like to see that? Okay, all right. So now how do we write a function like that? A function like that, when we talking about exponential function, the x, which is our independent variable, is on the exponent. That's why it's called exponential function. Okay, so y equal to, say, 2 to the x. That's what we did early on. So x is on exponent. It's called exponential. Now, what happens if a function which is like x to the, say, 20th or 12th power? Now here, the x is on the base, and this actually is called power function. But when the x is on the exponent, that's called exponential function. So that's the difference. And exponential function will grow way faster than the power function. Doesn't matter how big this one is. You could have y to the x to the 1000, but this will outgrow this eventually. Okay, and the function then, what we're looking at is, if you want to plot it, the plotting still, we just make a table. when x is 0, of course, y is 1. When x is 1, y is 2. When x is 2, y is 4. Then when x is 3 is 9. So when we're graphing it, we got this here. And when 1, we got 1. Got 2. Got 2. I got here. And 2 will be 4. And 3 will be 9. So we got line like this. Then what happens if you go to the negative side? Well, if x, same thing, x, y. If x is -1, what is our y?
0.
I don't know.
Oh, wait. No. Mm-hmm.
Our y will be 2 to the -1. What is 2 to the negative
Yeah.
1? Remember we learned earlier the
-2.
nope.
2 to the negative.
Remember we learned early on x minus n is 1 over xn. Okay.
Okay.
So that will be 1 over 2. So it's half. Now what happens x is -2?
Right.
What's our y?
That would be positive. Right.
What's that? It always positive. What's that?
Mhm.
If x is -2, what's our y?
1/4.
1/4.
Oh, 1/4. Right.
-3?
Uh, 1/8.
Yep, 1/8. So basically we can see that 2 to the -1 is half. 2 to the -2 is 1 over 2 to the square is 1 over 4. And you can see that it's getting smaller as going. And the thing is, you will never get approach to 0, or never cross the x axis, will never get to 0, but approaches to 0. So this is something we write is as x approach to -infinity, y approach to 0, but will never touch the x axis. So this is the graph of exponential function. You can see that from a long time, it's actually grow pretty small. But when they cross a threshold, it can become pretty big pretty soon. Good?
Aye.
That's hard to think about.
It's what?
I was thinking about how small you could possibly get, and it was just hard for me to imagine that there's no end. Sorry, I got very philosophical there for a moment.
Oh, very good, very good. I like that. I mean, math basically is the reason we have math is because people want to do philosophy. Okay, that's why the Greek is so big on math. It's because not because they like to calculate things, it's because they want to understand the natural world. And so that's what philosophy is. But the math provides a rational way of doing philosophy. So it's not just, fanciful imagination. It's something solid, something true. Okay, we got that. And another application actually you see in real life is when you invest money. And Jad talked about something called compound interest. And do you guys know what is compound interest?
Yep.
Okay, so can you say that in one word? What's compound interest?
Compound interest is something that grows over time or multiplies depending on the amount of interest, you know.
That's not
So
the
so
of
it,
it. That's
it
the
it's not
behavior.
great, but it's something that grows over time.
Right, that's the behavior, but not the essence.
I'm
Okay.
thinking the more you put in, the higher it doubles.
Well, that's not the essence. So the essence of compound interest is interest on interest. Good?
Hmm.
Now you can see. Now, if you put $100 in the bank, this is called your what's that called? Principal. Good. Now, if they give you, say, 4%. So do you guys have money on savings account?
Yes.
What's the interest rate?
I have yet to ask.
There
Well,
is none.
you need to check because nowadays depends on where do you banking. Some banks offer like 5%, and some banks probably give you 0.2. So very important. Okay, well, let's say you got 4%, and your principal is 100. Now we can show that after a year. So this is 1, 2, 3, 4, 5. Now after the first year, you put 100 in. After the first year, how much money do you have?
Let's say 4%,
Yep.
$4
So
or
104. Okay. So this is the interest on principal. It's called simple interest. Now, what happened on second year?
Have 208.
Well, no, because your principal is still 100. You earn another 4%, so it's 108. Good.
Okay.
That'd be so that would be what, $5.16. So that would be 105.16
Oh,
or
no, it's
5.6.
108 because we're talking about simple interest. Simple interest is interest on your principal, not on your
Mhm.
interest. Good.
That makes
Simple.
sense. Yeah.
Okay, on third year, 112, right?
Yeah.
So what is this growth?
Very slow.
This is something called linear. Okay, if you plot it, say a linear, and if you write that function, it's basically y equals to 100 plus 100 times 4% and times time. Okay, it's a linear. If you plot it, it's a linear function. Okay, now compound interest. If you put 100 in, the first year is 104. Now the second year, the interest is on this, the whole thing. So interest on interest. Now, it won't be that big difference for a couple years, for some years. The only difference is later on. So in this case, let's see, it's 104 and times 0.04, and then that gave us $4.16. Then we're going to add 104. So is 108.16. So that's no big deal. The second year then will be 108.16 times 4%, then plus 108.16. Now, so we got only 112 point, about 0.49.
Mhm.
Not much difference, right?
Yeah.
Well, for the few years, you won't see much difference. It's only later on it will become a bigger number. So we know the first one, our equation is this: 100 plus 100 times 0.4, right? 4% times number of years. Let's say it's t. Good. It's 100 plus 4 times t, right? Makes sense?
All right.
First
That's
year,
compound, right?
104 and what's
Is
that?
that the formula for compound
Nope,
interest?
nope. This is the formula for the simple interest.
Simple. This is simple.
Yeah, it's called simple interest. So the interest on your principal. Good.
Okay.
Are we good here? We all good? Okay, so now
Yep.
we're going to looking at what the compound interest, how to work out the formula. Well, we know that compound interest is this, y equal to our principal, 100. For the first year is just like this, 100 times 0.04. So it's basically, we can rewrite this as 100, 1 plus 0.04.
Oh.
Right? This is our
Mhm.
common factor, take out. So it's 100, 1.04. Okay, for the first year. Now, second year will be 100, 1.04 to the second power because we multiply that. And so therefore our formula then is this, y equal to 100, 1.04 to the t. Good. So now you can see that the variable t on the top one, simple interest, is a linear function we got here. But on the second one is on top of that. Now let's see after 10 years, what's the difference? In 10 years, the simple interest is 100 plus 4 times 10. That's 100 plus 40 is 104, $1.40. Not too bad. Then how about this is a simple interest? We got compound. Now is 100 times 1.04 to the 10. What is that? Well, that's where calculator comes in. 1.04 to the 10. Now we got, oh, times 100. So we got 148. Well, the only difference, $8. Not much, right? Oh, are we good so far?
That's not much difference.
Okay, yeah, because we still don't, not long enough yet. Now, when you put $100 now into bank, when for your retirement, when do you expect to take it out? How many years?
When I'm 60, so maybe 50 years.
50 years?
Yeah, because I'm
Oh.
18.
Okay,
So-
In a couple of years.
50 years. 50 years, simple interest is 100 plus 4 times 50. That's 100 plus 200, 300. Not too bad, right?
Mhm.
But for compound interest, 1.04, that's to the 50th power. What's that?
Shoot, I don't know.
1.04 to the 50th power. Okay, we got 710.
Whoa.
Now you see the difference. Good,
Mhm.
more than doubled.
So let's see here. So in first rate, it triples at 50 years. And then,
7 times.
well, wow.
Yeah.
I know it's just starts just climbing.
Well, of course, if you take a longer time, more than 50, that's definitely you got a lot more. But 0.4% is not that great. And normally, if you invest in stock, definitely I don't buy any particular stock. I put in a mutual fund. You guys know about a mutual fund, right?
Yep.
Could you enlighten me? I could probably use a
Mutual fund. Mutual fund is that they pool money together and buy lots of stocks. So you share, like say, and if I want to buy stocks, I don't have much money, so I can probably just buy one or two. But if we pool money together, like I got 100 of my friends together, then we can buy a lot more stocks, right?
Mhm.
So that we can spread out, so our risk is not that great, but we still get some return. You mean it's not super great, but it's relatively safe. If you invest on stock, you might get 10 times, or you might lose all, right?
Mhm.
You never know. So that's why they have the mutual fund. That is, they basically you have fund manager. They got fund manager who manages money, so you can pool the money. We pool all the money together. Like if you got like 1 million of us, then we probably got 100 million, right? And then we can buy a lot more stocks. Okay, so now stock market has go up and down, but um, you can reasonably got 7 or 8% in average. Okay, let's say you got 8% and you put money, right? Index fund, very good. So index just follow the you know uh, the index has just buy the stocks on the index. Yeah. Okay. So Asher, are you investing in mutual fund?
Not quite yet. I'm
Okay.
still too young,
Oh,
unfortunately, but
think
when I
about
turn 18, I'm investing.
it. Okay. Definitely. Yeah, never too young. Okay. The years work for you. So what happens, let's say if you put $1,000 now, and you got 8% compounding, okay? Has to be compounding, otherwise it's not exponential. Compounding will be 1.08, say, to 50 years. So how much money you got? 1.08 to 50. And here is how much you got.
Texting on the chat. Whoa.
Okay,
Whoa.
that's it. That's the compounding when things get interest on interest.
Wow. Yeah.
So that's why invest early. That's important. And have you actually heard of the phrase that pay yourself first?
Yep.
No.
Okay, let's say you got $1,000, and what do you do? Now, normally people just pay for the rent, right? And gas and food, etc., right? Maybe some debt. People get into debt, which is very bad. Well, the reason that is very bad is they also do the compounding, and their compounding is the interest rate is like 20% to about 30%. So so that's very bad on you if you like when we talk about credit card debt. So they actually makes a lot of money because the compounding works in their favor, but is against you. And so the idea of pay first, that principle, have you guys taken like Dave Ramsey financial kind of university, something thing like that?
I don't, but I read a lot about finance and learn a lot of
Right.
it.
Well, the first thing is debt. Okay, don't get into debt, especially credit card debt. Make sure there is a balance, the things you earn and things the income versus expense. Make sure income is greater than expense.
What do you do if you just can't help it? Like what you have to do is it's like very expensive and you need to
Well,
do it. Then
yeah, sometimes we have to get into debt, unfortunately, but there is also something called investment, not just money. Investment is also invest in terms, for example, invest on you yourself by learning a new skill, or sometimes maybe start a business. Good. So we
Mhm.
either increase income or we decrease expense. So this principle basically saying when you do the budget is that you always put aside a certain amount for investment, say like $1,000, before you spend money on some other things like a fancy iPhone or something. You put a certain amount, like say I put $100 per month. Okay, you put it aside, and so that's called pay yourself first. Then you got 900. Then of course you're going to have to pay something. You have to pay the rent. I don't know how much rent now, but right now it's pretty high. Maybe you got say $300 left, and that's how you spend on. But you pay yourself first, invest on that, and if you can invest $1 a month, and that things will grow like crazy. Good.
yes.
And that's something well we can work out next time to think about scenario. If you invest $100 per month and you earn at 8%, like after 50 years, how much money will be on your account? Think about that. Not that much, right? $100 per month. You guys can do that, right?
Yeah, that's actually pretty realistic for me.
Okay, in $100 months, put it into a mutual fund or index fund. Index fund actually pretty good. Then see how that things work out. Okay. And the next time we'll be able to derive a formula for this, and you can see the difference.
All right.
Okay.
All righty. See ya.
Good. Yeah. Yeah. Make sure you do the homework. Okay.
Yeah, I did send in the homework to you. I don't know if you got it.
Okay. I'll see.
I think it might be on Class Dojo again.
Okay. All right. It's better just send to my email.
Okay. Yeah, I can do that.
Okay, yeah, make sure that just send to my email and make sure you do all the homework. And if you need help, just schedule one-on-one with me, okay?
Okay, thank you.
Yeah. All right. Bye.
Bye.
Bye. Thank you.
Have a good one.
Yeah, you too.